Okay, so we're going to talk more about domains today and finding functions of functions this time. Like yesterday we did this. We'd have f of x, and it'd be x squared. And we'd have g of x, that's a weird looking g, g of x, and it would be like 1 over x. And then we would say, what was f of x plus g of x? It's not that hard. You just take this one and add this one. But now we're going to actually make you actually add them. Like, can you actually add these together? You can if they had a common denominator. So how could I make this have a common denominator? Well, if I put this one over 1 to show what its denominator is, do you get that I could multiply it by x down there, and then that would make me have the same denominator? And if I multiply by x there, I got to multiply by x here. And why is it okay to do that? Because I really am multiplying by what? By 1. See, because x over x is 1. And so this would become x cubed over x plus 1 over x. And now I can actually add them, can't I? Because they both have a common denominator. Okay, so the point is that it's going to get a little more complicated today. So stay with me. All right, to begin with, I'd like to ask you to just tell me, what is the domain of f? Don't say it, write it on your paper. What's the domain of g? Because if you don't know the domains of the parents, you can't find out the domain of the child. Write them on paper. So what you'd be thinking is this. All right, domain means like from left to right, the x numbers, that'll work. Well, is there anything that'll crash the first one? No, so it's all real. How about the 1 over x? Anything crash that? 0, just 0. So all reals work except what? X cannot be 0. All right, there's my domains. So then I don't even care what f plus g is, but what I want to know is, what would f plus g, if I added this and this function together, what would its domain be? Well, you overlap the two parent domains and you look at it there. So go ahead, do it. So tell me what the domain of f plus g. So you make a number line for the one on the left, a number line for the one on the right. You see where they overlap. Already done? Good. Tell me what you did for the top number line. All of it. Good. Shaded in everywhere. Okay. How about the bottom number line? Let's put a circle on 0. Open circle. Good. And then do these guys overlap? Yeah, they overlap here and there. So you might want to say it as negative infinity up until 0. And is it a bracket or a parenthesis at 0? Parentheses. Union with 0 to infinity. Could you say that as all real numbers except x cannot be 0? Yep. But when I'm looking at a number line, this actually comes to me a little easier than the all real numbers thing. So, all right. Raise your hand if you get that. Okay, good. So what are we doing now? Well, first I want to give you one problem from start to finish that I want you to try to figure out f plus g and like f divided by g. Do you remember when we did the divide by kind? I'll give you a 2-second reminder. Let's say I had these two and I was going to divide f divided by g. Do you remember how there was an extra what? An extra number line. You have 3 number lines to do. So then, if I wanted f over g, the domain of it would be 3 number lines. The first one was all reals. The second one was a number line where it only couldn't be 0. And the last one is a third number line where g could be 0. Now look at it. See how this would be bad if this was 0? We'll go to the g function, and the trick is Can you ever make that equal 0? Not crash, but be 0. Well, what would you put in? 1 over what would equal 0? 1 divided by 0 is not, it doesn't exist. It's not 0. There's no way to make this equal 0 right here. So if there's no way to make it 0, then there's no way to make this be 0, which means there's no way to crash it, right? Which means it's all real numbers again. So my 3 number lines look like this. And then where do they overlap? Same as before. There to there. I know some of you are probably still scratching your head about why you can't make this equal 0. Because this is the g function. If I have 1 divided by something, you tell me a number where I take 1 divided by that number and it'll make 0. There isn't anything. Can't do it. The only way you can make something be 0 is if the top is 0. I don't know if you've ever thought of that before. If the top is 0, then 0 divided by pretty much anything can be 0. The only exception is if it's 0 over 0, and that's not allowed. So basically the top has to be 0, and since the top can't be 0, then I can't make this equal 0. And therefore I can't crash it, and therefore it's everything. Let's do a more normal one though. Alright, here is f of x is going to be square root of x plus 2, and g of x is going to be 1 over x. Alright, I'd like you to figure out for me what would the domain... Actually, let's not just do domains. Let's actually figure out one of these. What is f plus g? Not the domain, just what's f plus g? Add the functions. So it's square root of x plus 2 plus 1 over x. Can I add them together right now? No, because they don't have a common denominator, but I could make a common denominator. Multiply by x over x. And then I can add them. And that would become x root x plus 2 over x plus 1 over x. And now they're both over x, and so now I can just add the tops. Final answer is x root x plus 2 plus 1, all over x. That's the two functions being added. All right. That's hard only because some of you have a hard time with common denominators. Like if I asked you to add 7 plus 3/5, you'd be really not sure exactly what the heck to do. If I want to add 7 plus 3/5, you could say 7 and 3/5, but I want this as one big fraction. Well, then you'd have to go to common denominators and say, this is really 7 over 1, right? What would a good common denominator be? 5 would be a good common denominator. So I times this by 5, and then that's the top by 5, and this would be 35 over 5 plus 3 over 5. And that means I can add them, and that makes 38 over 5. Do you get that? All right, so it's the same idea, except with letters like X. Okay, so now back to this problem. There's f plus g. Now, what's its domain? You're going to make yourself a couple number lines. You're going to overlap them. You're going to see what its domain is. Okay, so here's what you should do. You should figure out the domain of the first one, domain of f, and that one is, that stuff there, x plus 2 has to be bigger than or equal to 0. How many of you wrote that on your paper? Okay, good. That's a great start. Then you go x has to be greater than or equal to negative 2. That's its domain. Remember, you set whatever's under here greater than or equal to 0. Then over here, what's the domain of this one? Domain of g is everything works except what? 0. All real numbers where x cannot be 0. Okay, so then what's f plus g in its domain? Well, we did f plus g before. What's its domain? This one and this one have two number lines. One for this one, one for that one. Okay. It's confusing. I'm just going to write the two number lines. Okay. This number line is -2 like this. This number line is empty spot at 0, filled in everywhere else. Do you get that they overlap? Did you get that they overlap in two spots? They overlap from here over and between there and there. So it's from -2 to 0, where it can be -2 and it can't be 0, union with 0 to infinity. How many of you had that right? All right, that's only like half of you. People that had it wrong, do somebody be bold and tell me where you made the mistake. Because it shows me you understand your mistake. What? Forgot this little part? Thank you. I did yesterday too, so it's easy to do. Anybody else know where their mistake was? Just tell, because it helps other people understand their mistakes. Maybe somebody doesn't know. Okay, so what do we have to do now? We're going to start doing crazy things like this. F of g of 3. F of g of 3. Well, you get, if I just did f of 3, you get what to do there, wouldn't you? You stick in 3 into the what? Into the f function. All right. So if I go back to my screen that had my f of x and g of x, I'm going to use these same two functions because they're perfectly good functions. And I'm going to figure out what f of 3 would be. No, let's not do f of 3 because then that makes square root of 5 and that's kind of messy. So let's do f of 7. Everybody figure out what f of 7 is in your head. Don't say it. Just figure it out in your head. Got an answer? Is it a single digit? Is the number right after 2? Yes, and you did it right. So because I just stick in the 7 into this function, square root of empty spot plus 2. Notice I always put an empty spot where the x is. Notice this parentheses. There are going to be times when if you don't do it this way, you'll get it wrong, because there's times when that parentheses matters a lot. In this case, it really wouldn't. I'm just going to go 7 plus 2 is 9. But a lot of times it does, so I encourage you, use the empty spot technique. Then I have square root of 9, and that's 3. There we go. F of 7 is 3. So what the heck am I talking about if I do like g of f of 7? If I do g of f of 7, then what I want you to do is think any hard math problem, where do you always start it? On the inside, in the middle, okay? And then if I start in here, we just figured out 2 seconds ago, what's f of 7? What does it come out to, 3? Because f of 7, you stick it in here and you figure out, okay, 9 square root of 9 is 3. So f of 7 is 3. So isn't this the exact same thing as asking me what g of 3 is? Yeah, see how if you work it from the inside out, this isn't that hard. So what's g of 3? Well, then you go over to this function for the g function. You stick a 3 into it. And so then it would be g of 3 would be, put the g function with an empty spot, and then what, drop in what? So it's 1/3. All right, if you understood that, then you'll be able to do this. G of f of 14. All right, so g of f of 14. Did you start in the middle and do f of 14? That's what you should have done. What's f of 14? Just stick 14 in here, and I have 14 plus 16. What's the square root of 16? 4. Do you get how that was 4? Raise your hand if you had that at some point on your paper. Good. Next step, g of 4. Well, take the g function, stick a 4 in it. So here's the g function. Notice I always put an empty spot where the x is. And in this case, what should I drop in there? 4. Final answer, 1/4. Raise your hand if you had 1/4. Okay, good. Now, it gets harder. What? Actually, let's use the same functions again. It's just, I'll just delete them this way. What's f of g of x? Well, where do you start? On the inside, do you know what g of x is? Yeah, you do know what g of x is. It's right there. So, you go f of, and then instead of gx, what do I put in there? Really don't know if they, because they come down the stairs, I don't think that they realize there's a class right here. If they're doing it on purpose, yes, I'd like to beat them, bludgeon them with my... Oh, am I talking on tape? Yes, I am. Okay. Anyway, they're making incredibly annoying noises in the hallway, but I don't think they're doing it on purpose. Moving on. It's 1 over x. I got to do f of 1 over x. What does that mean? That means I got to put this into what function? All right. What I was going to say before, my mom always used the term, I'm going to beat you to death with a noodle. The idea was that it would not really be a real thing. It is frustrating when people like lots of noise outside the classroom. 1 over x into the f function. Well, where's the f function? It's right here. So I'd rewrite that with an empty spot where the x is. So I go square root of empty spot plus 2. And then I drop in this, 1 over x. So there's my answer. Raise your hand if you had that right. That's more than half. Okay, good. All right, let's do one more like that. New functions, though. Get kind of sick of those. F of x equals x squared. And g of x is going to be square root of x minus 7. I'd like you to figure out what is f of g of 2. Oh, I shouldn't have done 2. I should have done negative 2. Sorry. F of g of negative 2. Are you noticing something? What's weird? I'm just going to do the square root of a negative, aren't I? And therefore, what's the answer? No solutions. All right, don't be afraid of that answer. It's the right answer. No real solutions, anyways. Okay, now let's try it with f of g of 8. This one will actually work. Try it. If you haven't burned through at least 2 pieces of paper this hour, then you aren't doing enough on paper. Okay, so you start with g of 8. G of 8. 8 goes in there. 8 minus 7 is 1. Square root of 1 is 1. So it's really f of 1. Well, what's f of 1? Just stick a 1 in the x squared function. Empty spot, squared. Stick in a 1. 1 squared is 1. Raise your hand if you had 1. Okay, good. Now, here's the hard part. Remember how on all the other functions we could like add them and subtract them and divide them and stuff, but we always had to find their domains, and that was the hard part? Well, that's what we have to do now. Just find the domains on these things. So if I have f of g of x, and I want to find its domain, first thing I want to do is find the actual answer to f of g of x. So we'll start with f of x being x squared, and g of x being 1 over x. And I'd like you to figure out what f of g of x is. And by the way, the book and our worksheet often write it this way. F O G X. And I like to think of it as f of g of x, because I like to write it this way. And that's what I encourage you to do. because I know you'll know to start in the middle if you write it that way. But here, a lot of people start with the f function because it starts, with an f. And you shouldn't. You should start by doing the g of x. Anyway, so f of g means f of g of x. There's f of g of x. Where should I start? In the middle. What is g of x? They didn't tell me what x is, so I just put in 1 over x. So this is really f of 1 over x. And then I'm going to put the 1 over x into the f function. And the f function's right here. So I'm going to put an empty spot squared and put in 1 over x, and there it is. There is your answer. Raise your hand if you got that right. Now watch how to do the domain. You remember before I said to look at the two parents. On the other kind of problem, all you got to do is overlap the two parents. In this kind, it's a little more complicated. Not super complicated, but a little more complicated. All right. Let's look at what the parents' domains are. This one right here, the domain of the f function would be all reals. You get that there's no way to stop this thing? No way to crash it? Okay. What's the domain on this one over here? Domain of the g function. All reals except can't be 0. Okay, good. Can I make a number line for both of those? Yeah. But when I'm doing a function inside of another function, the way you can tell what the domain is you still have two number lines to overlap, but it's not the two parents. Do you get, how did I tell you to start this problem? By starting in the middle, right? Do you get, therefore, that if it crashes right then, that it'll be a bad thing? And so, therefore, the domain of the g function is important. Because if it crashes, if you put in a number that won't work in the g function, then the whole thing crashes. So, I got to start with this domain. So I make the number line for the g function. Here's the g, domain of g. And the domain of g is, let's say, that one's right here, and that's this one, and that's can't be 0. So I put an empty spot on 0 there. What do you think that has to overlap with? And it's not the other functions. It's not the other parent. The answer has its own domain. So we got to figure out what the domain of this combined function is. This guy right here. You do a new domain question on that. And you say, is there anything that would crash this? What would it be? If I put in what? Would it crash? The whole thing crash. This function right here. 0. If I put in 0. So my domain of my new function is the same as this one. It won't always be. And in this case, it's the same. 0 is the only thing that crashes it. And then I see where they overlapped. Did they overlap? Yeah. So it's still the same basic idea. You make a couple number lines and you see where they overlap. It's just you got to know what number lines to make. You make two number lines. One for the inside, because if that crashes, the whole thing stops right there. So we got to check the g function. Then we got to check the combined function's domain. And whatever its domain is, we put as our second number line. All right, I'd like you to try one more from start to finish. Here's what you just be expected to know how to do now. Let's say I had f of x, do f of g in a minute. F of x is equal to square root of x minus 2. And g of x is equal to 1 over x plus 3. I'd like you to figure out f of g of x. Remember how I showed you to write that? You got to get used to seeing it this way. It's probably the way the test will say it. But I like it when you nest it inside the other one. Remember how you do that? Figure out f of g of x, and then figure out its domain. This is like an R3 level question. It's an easier R3, but it's an R3. Here's how you start. F of g of x, nested inside. then start with the g of x. G of x is right up there, 1 over x plus 3. And then I want to find f of that. So this needs to go into the f function. So I take the f function. I write an empty spot where the x is. And then I drop in 1 over x plus 3. Then I have found f of g of x. Raise your hand if you had that correct. Good. Now, I'm going to have to make 2 number lines to overlap to see what the domain should be. I start with the inside one, the domain of the g. So I'm going to make my 2 number lines here, and I'd like you to start labeling them with what domain they are. The domain of g is the first one I'm going to check. That g function's up here. What is the domain of g anyways? It's everything works, all reals except x cannot be what? -3. Good. So here's -3. Can't be -3. Can be everything else. Then I look at this other function I just created, this new Frankenstein thing here. And I ask what its domain is. Is there anything that would crash that? Yes, there is. There's lots of things. Do you get that if this ever becomes negative underneath here, that this will all be done for? So what you need to do is go off to the side of your paper. This isn't supposed to be easy. This is Precalc. So we go off to the side of the paper and say 1 over x plus 3 minus 2 has to be what? What's the key with these root things again? They have to be what? Greater than or equal to 0. And that, when it's solved, will tell you what to put on your number line. So then I go 1 over x plus 3 is greater than or equal to 2. I just added 2 to both sides. Now I'm going to multiply both sides by x plus 3. I'll do that in blue. And that'll be 1 is greater than or equal to 2x plus 6. I'm getting close. 0 greater than or equal to 2x, and I'm subtracting 1 from both sides, plus 5. Whew, it's a lot of work. Sometimes they are. I'm just solving a little equation. Remember, keys. When you see square roots like this, you think greater than or equal to 0. Okay, and then I'm going to go subtract 5 from both sides. -5 is greater than or equal to 2x, and then I'm going to divide by 2 on both sides. -5 over 2 is equal to x. Whew. I'm going to rewrite that the other way. X is less than or equal to -5 halves. And there's one more thing I could do that would make me feel better about it. X is less than or equal to, isn't that 2.5? -2.5 feels better to me. So all that work to figure out my other number line. Yeah, that's going to happen. Not on most problems, but on our 3 level questions. Okay, so x is less than or equal to -2.5. So here's -2.5 would be a little farther this way. And it's less than or equal to that. So it could be that, or it could be less. There. Now is there overlap? Yes, and it's complicated overlap. This part's easy. Just overlaps in there. And this part's a little harder. So my final answer is from -infinity up until -3. And it does not work at -3. Union with, it does not work at -3, and it goes up until -2.5, and it does work at 2.5. Whew. There's your domain for this combined function. Wow. Now, if you want to feel any better about it, I just taught you all of tomorrow's lesson too. Okay, so today's worksheet won't be that hard. If you absorbed all of that, you're good for tomorrow. Tomorrow, I'm going to do it again. And hopefully if it didn't stick today, it'll stick better tomorrow. Okay? All right, so now let's do one of those problems at the bottom of your worksheet, because now they should be like easy peasy compared to what we just did. Would you read me number 9 off that worksheet. Numero. Okay, I got f of x, I got g of x. What do they want me to do with them? Find f of g of 3. Okay, I'm going to do that in green. F of g of 3. I'm going to write it this way. I know they wrote it FOG3, but I like to nest them. And I encourage you to write them this way because I think it's easier. And then you know where to start. You start on the inside. So it's g of 3. Go over here and see. Stick 3 in there. What do you get? 4. So it's really f of 4 then. So this is how you show your work on these. You got to show each little step. Stick in f of 4. And now, what's the 4 going to do when I stick it in the f function? Well, I should 2 empty spot minus 3. This is the showing your work part. 2 times 4 is 8, minus 3 is 5. There you go. Raise your hand if you had 5. Okay, good. You just figured out half of the question. Now, what's the other thing they wanted you to figure out? Is it f of g or g of f? G of f of negative 2. So start in the middle, figure out f of negative 2, stick it in there, get your answer. So when I do that, f of negative 2, it's going to be 2 empty spot, minus 3, stick in negative 2. That was this function right here. And then I get negative 4 minus 3 is negative 7. So I just figured out this part right here is negative 7. So g of negative 7 is my next step. And then g of negative 7, I got to go to this function right here, stick in a negative 7 there, and what do you get? Yep, final answer, negative 6. Did they even ask you for the domain? No. All right. Now, I know some of you didn't do an awesome job on the top of your worksheet because you probably didn't understand it terribly well yesterday, but by now, the top part should feel easy. It's just 2 parent domains, you overlap them, see where they overlap. The only tricky ones are when you're dividing, and then you have 3 number lines to line up. When you're doing a divide, remember, if you do like f of over g of x, then you want to have 3 number lines. 1 for f, 1 for g, the 2 parents, and then 1 other number line where g cannot equal 0. And you figure out what would make this function equal 0, and you have 3 number lines to overlap. And you see where they overlap. Okay, that's the hardest part of the top of the worksheet. All right, I think that's enough help for now. We have a fair amount of time left. I would be willing to start number 8 for you. Would you read me number 8? Cube root. You are a genius for bringing this up because so many kids are going to get this wrong because they're just going to say, oh, the domain of this, you just can't let this equal a negative number, and so 1 minus x cubed has to be greater than or equal to 0. That's wrong. You know why it's not normal? Because it's not a square root, it's a cube root. Let me make you think about cube roots for a second. Do you get the cube root of 8? What is the cube root of 8? It's 2. Because what? 2 times 2 times 2 makes 8, right? Do you get that it's okay to have a negative underneath the cubed root? Because you could have negative 2 times negative 2 times negative 2. This has an answer. Unlike a square root, this is okay. It's okay to have a negative underneath there. So it's just negative 2 for an answer. So what's the point? The point is, I don't care if this thing is positive or negative. Therefore, it's all reals. You don't have to do this thing. You can't crash a cubed root. You can crash square roots because they can't be negative. But cube roots, they can be negative. So you can say that this is just domain of g. The g function doesn't have any limits. It's all reals. Can't crash it because it can be negative underneath the cube root. All right. So that doesn't answer the whole question. It answers one important part of it that a lot of kids screw up. The other part, domain f The domain of the f function is all reals again. So now if I'm going to overlap all reals with all reals, that's going to be pretty easy, right? Okay, but then there's one extra catch. On this kind of problem, I think you were doing divide, right? Then they want f over g. Okay, so if they want f over g, first step is to figure out what is f over g. Well, the f function is x cubed. Over the g function is cube root of 1 minus x cubed. Do I expect you to actually multiply that out or anything? No, that's done. That's good. But when there's a divide problem like this, you have three number lines. Domain of f, domain of g, and then the one extra one. Right? Which is, could this thing equal 0? And yes, there's a way to make the bottom 0. So you need three number lines. All reals. And then the third number line is, what if this was equal to 0? And there's a way to do that. So you have to figure out what the third number line is, and then you see where they all overlap. How could you make this equal 0? You have to think it through.